In this class we'll be talking about special processes. So special processes are certain processes in which we can simplify them by either isolating certain properties that do not change or identifying portions of the property that we will isolate or discount. So in a special process, we use the symbol of circling the property. We mean that we hold that property constant. So if you see a variable that has a circle around it, it means that that property is held constant throughout the entire process. So the first special process we'll talk about is isothermal. Isothermal is a process in which the temperature of the system remains constant. So iso comes from the Greek for equal. Thermal, you can think of as heat, it's temperature. So equal temperature, so it's the equal temperature at both ends of the process. Okay, so every time you see iso, that means we're holding that property constant. In this case, thermal refers to temperature, so no change in our temperature. Next special process we have is isobaric. Isobaric is when you hold the pressure constant. One way to think of it is, if you've ever heard of a hyperbaric chamber, hyperbaric chambers are used for divers if they come up too fast. If their bodies experience a decrease in pressure too quickly, use a hyperbaric chamber to increase the pressure on them. Also, you can think of a barometer. So that baric, barometer, hypobaric, that's a pressure relation. So when we say isobaric, we're saying constant pressure. The third special process we'll talk about is isometric. You may have heard it in Europe, they refer to it as isochoric. We'll use isometric in this class. You can think of it as it's for holding the volume constant. You can think of volume as measured in meters cubed. You can also think of geometry is how we describe a volume. So isometric, holding the volume constant. And the last special process we'll talk about is adiabatic. And adiabatic, it's not holding a property constant, but what it is doing is isolating the process to say that this process will not involve heat transfer. So heat transfer for that process will be 0. So if you hear that something is fully insulated and adiabatic, that means that there's no heat transfer occurring during that process. Now, adiabatic does not mean that the temperature is constant. It only means that there's no heat transfer going in or out of the system.